Hey, so now let's talk about horizontal compressions. We're gonna compress it horizontally or stretch it horizontally, okay? Okay, so an example will be square root of, let's say, double of x. Okay, so what does that times by 2x do? That's the question. Okay, so let's plot some points. Okay, x, y, plug in 0, it remains as 0. Plug in 1 in there, you get root of 2. Plug in 2 in there, and you get root of 4, so it's 2. Okay, so look. 0, 0. At 2, it's 2 already. Okay, so compare that with the original function where root of 4 was 2, right? And then here it was like this. So it looked like that versus the new one here. It looks more like this. So if you just look at the picture, well, it looks like it's going up a bit. But what's actually happening, okay? What's actually happening is that this point here moved there. Okay, and this one value actually moved to there. Okay, so that if I were to draw this a little bit more accurately, at half, if you replace x with half, you get 2 times half is 1, right? That's 1. So like that. Literally all the x values, so the 4 shrunk to 2, and the 1 shrunk to half. All the x values are shrinking by a factor of half, okay? So the wording is a little bit confusing, but the convention wording that most textbooks follow is that we say this is a horizontal, okay, compression because it's compressing, and we say by factor of half. Okay, we use a smaller half to describe what's happening to the horizontal lengths. Okay. All right. So in terms of transformation mapping, x compared to the original, okay, the original function of the parent function of root of x, it gets divided by 2, and y doesn't change. Because we're affecting the x, it's a horizontal transformation, and because we're dividing by 2, it's a compression. Okay, compression. Okay. How do we stretch it? What do you think? What would be your guess to stretch this parent function? Okay, instead of multiplying by a larger value, we multiply by a smaller value. Okay, square root of half of x, or 0.5x. So note that here, 0 is still 0, but I need to put in 2 to get square root of 1, okay? And instead of 4, I need to plug in 8. Okay, if that's 4, 8 will be about there to get the same 2. Okay, like that. So what's happening compared to the original function? I mean, can you already see it looks horizontally stretched? So here's the original function. At 4, it's 2, right? So this point moved there, this point moved there. It's like all the points being dragged to the right, okay? And more precisely, this length, the length of 4 became 8. This length of 1 became double. Everything is stretched by 2 times, okay? So here we say it's a horizontal stretch, okay, by factor of 2. Okay. So note the different wording I'm using. I'm using stretch. Up here I use compression. Okay. And its compression is always described with a fraction, and stretch is expressed with a value that's larger than 1. Okay, lastly, the transformation mapping is 2x. and y. Okay? Can, of course, use that. 0, 0 doesn't go anywhere, right? But 1, 1 moves to 2, 1, and 4, 2 moves to 8, 2, right? We just plug those values into this expression of 2x. Okay, so that is horizontal stretch and compression. Okay? All right, I'll see you in the next one.